Okay, thanks. So hi everyone. Thank you so much for being here today. I'm very happy to have this opportunity to present this new tool that we are working on. It's an aggregator for metadata about water-related data, and we are hoping it can facilitate the discovery of this data for a range of different users. At the moment, we are using the working name Mosaic, but it's not set in stone. We're just starting. So this is the plan for the presentation. First, I will give you a bit of context about the company I work for and how this project came about. And then I will talk about the project itself. After this, Julien is going to show the interface and then present the next steps for the project. And then at the end, there will be a time for questions and comments. So at CannForecast, our mission is to leverage data for proactive management of water resources. The company was founded in 2016 after winning the aqua hacking competition for the St. Lawrence River with what became the IntelliSwim product. So in waterways, the fecal indicator bacteria E. coli and Enterococcus are both used to determine if the water is safe for aquatic activities. And the methods currently used require incubation, which takes about 24 hours. So during this period, people are exposed to waterborne diseases. So what we do is we develop AI models to allow us to make predictions in real time and for the next 3 days for what the bacteriological quality of water will be. So for IntelliPipes, the problem being tackled is that water main breaks represents an enormous burden for municipalities with the damages and costs, and with high damages and costs, and resources to modernize networks are limited. So being able to identify the pipes that are more at risk of breaking allows for a more efficient proactive management. And IntelliPipes uses AI to do that. So we work closely with our customers, which some of which you can see listed here, as well as our research partners. And nowadays we are working towards generalizing IntelliSwim for other usages like the treatment of drinking water. And the IntelliPipes team is working on predicting flow in water pipes. So with the pandemic of COVID, we all started working from home, and I have taken this opportunity to move to the countryside in the village of Saint-Didas in Lanaudière. The Masquinongé River is passing right there in my backyard. The picture you see is taken from my backyard. And I really wanted to know how safe it was to swim in the river. And at CannForecast, we have an entrepreneurship program that we call the Friday Project. It allows us to spend about 10% of our time on a special project that is related to our field of work. So I set out to find out everything that I could about water quality in my river. So I first found out that in the southern part of the province of Quebec, for each watershed, there is an organization that prepares a water management master plan that includes a description of the present state of the watershed, as well as some orientations for the future. So that was a great place to start. But after reading the document, some things were not clear. The water quality in the river is much better upstream because this part is mostly surrounded by forests, and the downstream part is more affected by pollution from agriculture and other sources. So I wanted to find out the exact locations of all the sampling stations to determine which results were relevant to my particular section of the river. So this was a very long and tedious process, even for me who works in this field. So it made me think how great it would be to have an aggregator for metadata about water. So I pitched the idea to the team, and some people came on board. So we set out to make it happen. It takes the form of a map with data points indicated with dots, which we can select to see some metadata about this data source. So location, data source, and some other information that is available. And when possible, a link to the data itself, or otherwise a general link to the data provider. So our goal is to facilitate the access to open data, specifically at the step of discovery, and to help the user identify what measuring or sampling stations exist in a certain region across a range of sources from different fields. So our users could be businesses looking to leverage the available data to solve problems related to water management, like us at CannForecast, because at each new location for which we develop an IntelliSwim model, identifying the available data sets and the nearest stations for hydrology and this kind of thing, it's a time-consuming task. We work mainly with precipitation, but also overflow, wind, temperature, and other variables. And we are also always testing new variables in order to try to make our models always more accurate. But we are also hoping that students, researchers, citizens, or groups will also use our tool, because we believe that better data access promotes better science. And we also think it's a great way to promote democratization of knowledge and citizen participation in water resources management. So that's why we're going to make this tool available free of charge. So we started working on this only last summer. We are still at the first steps. So far, we have chosen some data sets to include in the MVP. And we have been working iteratively to find a format for the database that makes sense with the interface that we want to build. So as we go, we identify issues and work on finding solutions. Some challenges that we're facing at the moment is that the metadata from different sources all have different formats. And when data has been compiled from different sources, it can be hard to trace back where the data originally came from. And there's also overlap on the map because some stations are used for multiple monitoring programs. So the way to manage all this is not straightforward. And we really want to keep the tool very instinctive to use and user-friendly. So we're still working on it. So this is the data that's available for now. We started with the data sets that we were most familiar with. First, the weather data from Meteorological Service of Canada. After that, we added some data sets from BQMA, which is the MLCC data bank on the quality of the aquatic environment in Quebec. This includes many data sets. One of them is Réseau Rivière, which is a physical-chemical monitoring program for Quebec's main river. We also have EDEC, which is an indicator of water quality that's based on the observation of diatoms. So those are microscopic algae with an outer skeleton of silica. And for some species, they do not tolerate any pollutions, and others proliferate in a polluted or eutrophic environment. Then we also have SOMAE, which is the monitoring program for wastewater works in Quebec. We also included the flow data from the Water Survey of Canada hydrometric station. And we also added the Environment Canada water quality monitoring data. And that's when we realized that the data set includes data from the provinces. So we're still figuring out how to handle the duplicates. Those are some other sources that we are thinking to add next. So there's more data sets from BQMA. For flow, there is Hydro-Québec and the Hydroclimatic Atlas of Southern Quebec. For weather, we were considering adding data from NOAA in the US, but we decided to focus on Canada for the moment. And we would also like to showcase the equalized samplings made in the context of the Environnement Plage program, which monitors all public operated beaches in Quebec. But this is not available in the form of an open data set, so this could be hard, so maybe not going to be a priority. And now, in terms of the north, it's easy to notice that there is a lesser density of data points in the north. You'll see when Julien makes the demo later. We think that since there is less data, we should try harder to get all the relevant data into the tool, so we can compensate in part for data scarcity by achieving a better coverage. But we know that we're going to need help from collaborators to do that, to figure out what is the relevant data and where to find it. So far, I identified some data catalogs that are for academic research, like the Polar Data Catalog and Nordicana D. But these all seem to have a learning curve, and they cover a large range of topics. So we will have to determine which ones falls within the scope of the project. And one obstacle for me is that I'm not familiar with the use cases for the north. For example, the way that drinking water and wastewater is managed is different from the south. And another example, contamination with heavy metals is measured in animals and fish, and not directly in the water. So for me, this would fall into water quality, but it's not the kind of sampling that I would first think of. However, there is one use case that I'm aware of because I have a friend who works as a midwife in Kuujjuaq. So toxoplasmosis is a waterborne protozoa linked to health issues, especially in pregnant women and immunocompromised populations. So as far as I know, the official recommendation from the government is for pregnant women to avoid certain traditional foods during pregnancy. But this is a complex problem because with food insecurity, depriving people of the nutritious traditional foods also represents a health risk. So I could really see a potential here for developing predictive models in this field in the future. So in order to do this, you would also need to add the marine currents because they play a role in transporting the toxoplasmosis oocyst. But there's probably many other variables that I'm not thinking about that would also be necessary. So this is the kind of data that we would like to have in the tool. So hopefully in the next step of the project, we can find collaborators to help guide us, because we don't only need to determine what is relevant or not, but also to prioritize what would be especially useful, because we have very limited resources to advance the project. And now Julien will do the demo.
Thanks. I'll reshare my screen. All right. So hi everyone. I'll do a quick demonstration of our current web app. So currently it's in an MVP stage, and this is the current version that we have right now. So I'll go over a bit of the functionality and take the perspective of a user that's interested in climate data in the region of Whitehorse. So right away, you can see that on our map, we have all the different sources on the left in this legend. And you can click and select individual sources depending on which you're interested in. So in our case, if we're only interested in climate data, we can disable all the other ones and only have stations that represent this data remain on the map. Next step to select stations would be to click and drag to create a bounding box. Doing so lets you select all the stations that you're interested in. And once you release, you'll see all the information appear on this pop-up, which Noémie went over before. So we have things like station names, descriptions, and Latin long. And also, as she mentioned before, we have URL sources. So for URLs, we have two different cases. Very general information, which will bring you to the website of our sources, or if possible, it will bring us directly to a CSV of the station values. In this case, we can see that we have all of our sources are linked directly to the general website. Once you have all of the stations selected, you also have the option of exporting these by clicking on the export button. These will download all of the values in a CSV format. Doing so will keep all of your fields, including the URL. So this would be more of from the perspective of someone that wants to collect data and use it later on in the CSV format. So this is more or less what we have right now for our MVP. Before continuing, does anyone have any questions or comments before I continue the slides?
I don't see any questions in the room.
Great, thanks. So as I mentioned, we have a few next steps planned for the future. So the first one would be to research and to eventually choose a license type. This would most likely be a license relating to open data. So we'll have to take our time and go over the different types of licenses and choose one that makes the most sense for our project and go through all the different application forms. Our second goal would be to make the web application accessible online. So the goal of that would be to release our MVP and get users to start testing it. And really the goal there would be to start getting feedback from users and finding out what's useful and what's not, and start planning out improvements that we can make on the web application. So this kind of leads to our next step, which means which would be opening the project for collaboration, which is one of our primary goals. Making a web application open would bring up a few questions of how we could make this an open source project. So we have a few ideas. We were thinking that we could let people submit data either directly by having some type of some interface online and letting users submit data directly through our website, or we could do something more simple as simple as letting participants email us suggest data sources that we could later integrate ourselves. So this is one of the questions we want to answer by publishing our web application and seeing what the easiest way to make it open source would be. This would lead to a few more questions about how we would validate our data. Also, it would most likely require us to publish our database format. So the goal would be to reduce the amount of time we spend formatting data and letting people know what format we expect the data to be, to really reduce the amount of time we spend processing and cleaning data before uploading it. We have a few ideas for development as well. Our main goal is to make our web application as minimal as possible and have really only have features that make sense and are used by users. That being said, we had a few ideas of future development we could have, which would be integrating raster data to show different types of data sources, such as territory use or rainfall or elevation data that we could display on maps. Another one would be having the option of uploading areas of interests. So this would take the form of users uploading their own GeoJSON or shapefiles and using those areas to overlap our map and select stations based off areas they're interested in. And also incorporating reports and studies related to our station data that could be downloaded by users in the future. So I'd like to, in closing, I'd like to present our team. You've already met Noémie, our data scientist, who conceptualized the project and spent a lot of time working on metadata design and planning our database structure and finding sources. Myself, who's worked on the web application and web design. We have Nicola, who's has a background in biology, who helped us identify sources and plan feature development for our application. Jack, who is specialized in Flask and DevOps, who has helped us manage the application and deploy it on our platform. And Rachel, who has a background in hydrogeology, who's helped us review sources and plan features as well. So if anyone has any questions or comments, I think we're ready.
Great, thanks so much for the presentation. I do see a question in the room, so I'll pass the mic right now.
Yeah, Julien, thanks for the presentation. And Noémie, as far as funding goes, I see the ECCC logo over there. Moving forward, I'm going to go out on a limb and assume that ECCC provided seed funding to develop this product, but CannForecast is a private company. Moving forward, how is this project going to be paid for? By user fees, or is there ongoing funding via ECCC?
No, actually, we have no funding whatsoever. This is, like I said in the beginning, with the Friday project, we work at Can, all of us, and we can use 10% of our time on this project. So you could say that the project is financed by CannForecast at the moment. And we would be open to receiving funding externally. But yeah, for now, it's just us.
Okay, and if users were to sign up for this, what sort of guarantee would we have that fee structures would remain the same, or that they would evolve in a certain predictable manner?
Well, at this point, we don't have any guarantees because we're still only beginning, and we don't have a master plan or a 5-year plan or anything like this. But maybe we would always keep like a free version for regular users, and if there was some people willing to pay for a more advanced version of the tool, then we could see and work with them to develop this. But at this point, there's no goal of making money with this project. We're just doing it because we believe it should exist.
Okay, thank you.
Great, thanks so much. Any other questions? We can fit in a quick one if there's one more. Seeing none, thanks so much for the presentation. Thanks everybody for coming.
Thank you.
Thanks.